Chapter 1, Section 3 is about average rates of change. Average rates of change is going to be the ending amount minus the beginning amount, the two output values, divided by the number of units in between, so the subtraction of two input values. So you know this already as slope formula, looking like y2 minus y1 over x2 minus x1, where you can't use the same point. It has to be two different points. Or we could express it in function notation and say f of b minus f of a, so the two outputs over the difference of the two input values. And again, you have to use two different points. You can't use the same point, or you're going to have 0 over 0. So basically, this average rate of change is just the slope of the line that connects the 2 points. Now, as far as linear functions or lines are concerned, the average rate of change is consistent. It's constant. It doesn't change. You can pick any 2 points you want. You're always going to come out with the same number. However, when you talk about the average rate of change of a nonlinear function or a curve, it's going to change depending upon the points you pick. I mean, it may be the same depending upon points you pick if you're lucky, but normally it's going to change from point to point. So let's take a look at this with a curve. We've got our curve right here, y is equal to x squared, our quadratic. It's asking us for the average change from the points where x is 1 to the point where x is 3. So let's get some ordered pairs here. If the input is 1, 1 squared is also 1. If the input is 3, 3 squared is going to be 9. So this point, and then this point here. So the average rate of change will be 9 minus 1 over 3 minus 1, which is going to be 8 over 2, which will be 4. So the slope of the line that connects those 2 points is 4. If we're considering the points where x is 1 and then x is 2, we've got 1, 1. This time our second point will be 2, and 2 squared will be 4. It's going to be 4 minus 1 over 2 minus 1, which is going to be 2 over 1, which is just 2. So the average rate of change between the points did change. Okay, and 2, 4, that would be about here. Now the last one says when x is 1 and then x is 1.5. So 1, 1 for a starting point, and then 1.5, well, I square 1.5, I get 2 1/4. So if we do the difference, 2 1/4 minus 1 over 1.5 minus 1 would be equal to this mixed number as an improper fraction. 2 times 4 is 8, plus 1 is 9, and then 1 whole is 4/4 for common denominator. So 9 minus 4 will be 5/4. Over 1.5 minus 1 will be 1/2. Now remember, when you have fractions and you're dividing, you change the operation to multiplication and multiply by the reciprocal. So instead of 5/4 divided by 1/2, it will be 5/4 times 2 over 1. So the 2 and the 4 will cancel, making it a 2 here. So the slope between those 2 points, 1, 1 and 1.5, 2 1/4, is going to be 5/2, which is about 2.5. Okay, so 1.5, 2 1/4, out here. Alright, secant line will be the lines that pass through your graph touching in 2 places. We just found the slopes of 3 secant lines. The first one was this line that passed through 1, 1 and 3, 9. The second one passed through 1, 1 and 2, 4. And then the third one passed through 1, 1 and 1.5, 2 1/4. Alright, difference quotient. Difference quotient, again, is just like slope. We've got an output minus an output over, if our first input was x plus h, we would have x plus h here, minus the second input was x. So the x minus the x canceled, and all that's left here is the h. All right, what are the steps to figuring out this difference quotient? Very first thing you're going to do is evaluate this part of it, the f of x plus h. So evaluate and simplify f of x plus h. The second thing you're going to do is substitute in the expressions for the f of x plus h and the f of x. Make sure you use parentheses, particularly after that subtraction sign. When you subtract expressions, you subtract every term, not just the first one, so the parentheses are very important. Okay, we're going to substitute the expressions in, and we're going to utilize parentheses. And then the last thing you're going to do is to simplify completely. Okay, so you're going to go ahead and distribute the minus sign, combine like terms, factor out an h, and cancel the h away. So let's do a couple of problems like this. At the very top of this paper, we're going to go ahead and write the difference quotient, f of x plus h minus f of x all over h. H can't be 0 because if it is, this fraction is undefined. Division by 0 is undefined. Very first thing that we're going to do in part A is find the difference quotient. So first thing is find f of x plus h. That means replace all x's with the quantity x plus h. Okay, notice I use parentheses here because I've got to square this. When you square a binomial, it comes out as a perfect square trinomial. X times
x will be x squared. Both inners and outers will be x times h. So x times h plus x times h will be 2xh. Plus the product of the last will be h times h, or h squared. Last step is to distribute the 5. So 5x squared plus 10xh plus 5h squared. Alright, in part 2 now, we're going to substitute these expressions, this one and 5x squared, up here, and then we're going to simplify. So I've got 5x squared plus 10xh plus 5h squared minus f of x, which is 5x squared, all over h. Now this one's kind of simple because it only has one term, which is really nice. So the next thing we're just going to do is combine like terms. So this positive 5x squared and this negative 5x squared are a pair of opposites. They cancel, becomes 0. So we've got 10xh plus 5h squared all over h. We're going to factor out the common h in the numerator. H times 10x plus 5h all over h, and then these two are going to cancel each other out, leaving you with 10x plus 5h. Okay, that's part A. In part B, we have to evaluate the quotient for x is equal to 5, and h is equal to 1, and then h is equal to 0.1. Alright, so 10 times 5 plus 5 times 1 will be equal to 50 plus 5, 55. In the second instance, where x is 5 and h is 0.1, it will be 10 times 5 plus 5 times 0.1, which will be 50 times 0.5, so 50.5. Okay, for the second one, g of x is equal to x squared minus 3x plus 5. This one's going to require a little more work because of the three terms. First thing we're going to do is find the difference quotient. So g of x plus h will be equal to quantity x plus h squared minus 3 times the quantity x plus h plus 5. All right, we're going to FOIL and distribute. If there were like terms, we'll combine them. X plus h squared, we keep doing this, it's x squared plus 2xh plus h squared. Distribute the minus 3, so minus 3x minus 3h plus 5. All right, no like terms. So in part 2, we're going to substitute this expression in for the g of x plus h. So x squared plus 2xh plus h squared minus 3x minus 3h plus 5. And we're going to subtract from that the original function, which is x squared minus 3x plus 5, all over h. Okay, now we have to simplify this. So first step is going to be get rid of these parentheses by distributing this minus sign. These parentheses can just come off. There's just the understood plus 1 up here, and 1 times anything is itself. So x squared plus 2xh plus h squared minus 3x minus 3h plus 5 minus x squared plus 3x and a minus 5. And we distribute the minus 1 all over h. Let's go ahead and combine like terms. We've got a pair of opposites here. Those cancel away. A pair of opposites here and a pair of opposites there. So all that's left is 2xh plus h squared minus 3h all over h, factoring that common h out in the numerator, and then canceling it away, leaves us with 2x plus h minus 3. Okay, part B, let x be 5 and h be 1 initially, so 2 times 5 plus 1 minus 3 will be 10 plus 1 is 11, 11 minus 3 will be 8. And when x is 5 and h is 0.1, it'll be 2 times 5 plus 0.1 minus 3, which is going to be 2 times 5 is 10. Community property says I can jump over and subtract this 3 from this 10. So 10 minus 3 is 7, and 7 plus 0.1 will be 7.1. Okay, problems like this can be found on page 122, problems numbers 1 through 43.